Today, we are going to learn about solving a little bit more complicated trig equations. But before we do, I want you guys to grab a piece of paper, some random piece of paper, and we're going to write some things that we learned with the hand trig that we are going to need to be able to do all of these problems. And so we're going to practice writing this every day. You are going to get tired of it, but that's okay. So first, I want you to draw a little hand. Now, I am not good at drawing. All right, and then we're going to label the angles, the fingers, as the angles that they are. Okay, so that's one thing that we're going to need to be able to answer these questions. Right, then another thing that we're going to need is the fact that all students take calculus. Okay. And then we're going to draw the quadrant angles and label them. So the quadrant angles are 0, pi over 2, pi, and 3 pi over 2. And also 2 pi, but we're not going to give an answer of 2 pi on this assignment, so we're going to leave 2 pi out. And so we're just going to put a point that's 1 unit away from 0 on all of those and label the coordinate of that point. All right, and then also we need to write what we would do to find the sine, cosine, and tangent of those angles using those points. And so if we're going to do the sine on the unit circle, we're just going to use the y coordinate. Cosine of theta is the x, and tangent of theta is y over x. Okay, and then we also need to know these special angles in other quadrants. So let's start with pi over 6. Okay, so there's a quadrant plane, and then we'll draw like a little X. We'll say it's about pi over 6 corresponds with 30 degrees, so that's close. So this angle is pi over 6 because we rotate pi over 6 from the x-axis. Right, this one we also rotate pi over 6 from the x-axis. So it's like 1/6 less than 1 pi, and so that's going to be 5 pi over 6. All right, the next one is 1/6 more than 1 pi, so 7 pi over 6. And then 1/6 less than 2 pi is 11 pi over 6. So I feel like the pi over 6 one is the most difficult one to remember. All right, and then we will also do the same thing for pi over 4. Now the pi over 4 angles are easier to remember because as we go around, it's the next odd number over 4. So it would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, and then pi over 3 isn't too bad either. All right, so that one's pi over 3. The next one would be 2 pi over 3. All right, and then we rotate again. This is 3 pi over 3, or just pi. And then we have 4 pi over 3, and then 5 pi over 3. The next one is 6 pi over 3, which is 2 pi. Okay, so this is something that we are going to draw every single day until you guys have it permanently in your brain. All right, so now let's solve some equations. So for example 1, we're going to find the solutions of the equations in the interval from 0 to 2 pi. And this does include 0 and does not include 2 pi because I have the parenthesis on that one. All right, so we want to find an x, an angle, that has a cosine of, oh, there's one more thing we need to write. Sorry. We have a cosine of 1/2. So the other thing we need to write is what we do when we do the hand trick. Sorry. So if we're going to use the hand trick to do the sine of an angle, it's going to be the square root of the bottom fingers over 2. The cosine is the square root of the top over 2. And then the tangent is the square root of the bottom over the square root of the top. Sorry, that should have been closer to the hand. So those definitely go together. So this one, we want to find an angle that has a cosine of 1/2. So it's positive. So cosine is positive in quadrant 1 and quadrant 4. All right. And then for cosine, it's the square root of the top over 2. So that means we want one top finger. Okay. So if we're looking at the hand, the angle that has one top finger is pi over 3. So x equals pi over 3 is one of our answers, because if we take the cosine of pi over 3, we get 1/2. All right, and then we need to know what pi over 3 is in the fourth quadrant. And luckily, we just wrote that. Pi over 3 in the fourth quadrant is 5 pi over 3. Okay. All right, let's look at B. For B, we want to find an angle that has a sine of negative square root of 2 over 2. All right, so first, we want the sine to be negative, and what we know is that sine's positive in quadrants 1 and 2, so sine is negative in quadrants 3 and 4. All right, and then according to the hand trick, if we're going to find the sine of an angle, we're going to do the square root of the bottom over 2. So for this problem, that means we want 2 bottom fingers. All right, so if we look at the hand trick, the angle that has 2 fingers below it is pi over 4. But pi over 4 is not one of our answers, because the sine of pi over 4 is positive square root of 2 over 2. So we want pi over 4 in quadrants 3 and 4. So that's going to be 5 pi over 4 and 7 pi over 4. Okay. So that was kind of like what we did on the hand trick lessons. It's a little bit of a review of that. If you haven't watched the hand trick lesson, you probably need to go back and watch that before you do this lesson. So anyway, when you're not given an interval in which to find the solutions, there is an infinite number of solutions. Therefore, you must give a general solution. All right, so I do have a graph on here to show you that because sine and cosine and secant and cosecant and tangent and cotangent are periodic functions, that you're going to keep, like it's going to repeat that pattern over and over and over again. So you're going to get an angle that has a cosine of 1/2 over and over and over again. All right, so here we go. We're going to first start off by solving this equation for cosine of x by adding 1 and dividing by 2. Okay. And then it ends up pretty much being what a is, except this time you're not given an interval. It just says to solve it, like find all the solutions of it. And so we want to, this is the graph of cosine of x. And I would say this is 1/2, about right there. Okay, so I'm going to try to draw a straight line. I'm not going to be perfect, but that's okay. Okay. So just in this, it's like 2.5 periods. We can see that there's 1, 2, 3, 4, 5, 6 solutions. And then it's just going to keep on repeating this over and over again. So I can guess what these two are. The ones that are between 0 and 2 pi is going to be what we just got. This one is going to be pi over 3. And then this one is going to be 5 pi over 3. All right. But we can also represent the others. So this next one right here is where this period is repeated again. So it's actually going to be pi over 3 plus the period, plus 2 pi. Okay, and I bet you guys could guess what this one is. This one is going to be 5 pi over 3 plus 2 pi. All right, and then this one is going to be pi over 3 plus another period, so plus 4 pi. All right. This one right here is going to be this 5 pi over 3, but because we're moving on this side, is going to be minus a period. Okay, so if you're not given an interval like between these two, and if you guys look at your assignment, I'm pretty sure on most of them you're not given. Okay, so on the first 6, you're not given an interval. You're just told to solve. So we will have to give general solutions. And then on the last 2, you're only finding the solutions between 0 and 2 pi. All right, so to give general solutions, you're going to add 2n pi for sine, cosine, secant, and cosecant. All of the trig functions that have an original period of 2 pi. And then for tangent and cotangent, you only have to add n pi because they have a shorter period. Okay, so we'll do some of these. It's going to be okay. All right, so this one, I changed the problem. It's not super neat. This is the equal sign. So we're going to solve the equation cosecant x minus 4 equals negative cosecant of x. All right, so the first thing we want to do is get our cosecants on one side and our 4 on the other side. So I'm going to start off by adding a cosecant of x. So 1 plus 1 is going to be 2 cosecants of x. All right, and then I'll add the 4 and divide by 2. Now, I don't have a hand trick for cosecant or cotangent or secant. So what I would do at this point is just do the reciprocals. So if I have that the cosecant of x is equal to 2, what would that make the sine of x equal to? That would just be 1/2. So then I can do the hand trick. All right. So this is a positive, so I know I'm going to be in quadrant 1 and 2 for sine to be positive. So that's where sine's positive. All right. And then according to the hand trick, for sine is the square root of the bottom over 2. So that means I want 1 bottom finger. And looking at the hand and how it's labeled, one bottom finger corresponds with pi over 6. So I know pi over 6 is one of my answers. Now, because I'm not given a interval to give my answers in, I'm just told to solve. Oh, I never finished that first one. Sorry, I'm just told to solve. I'm going to add 2 in pi. All right, and then in quadrant 2, pi over 6 is 5 pi over 6. And I would add 2 in pi to that. Okay, now let's go back and finish this one. Sorry. And so we already know that in that first quadrant, we get pi over 3. But to represent all the other solutions as the period continues, you add 2 in pi to that. Right, and then we also have 5 pi over 3 here. But then to represent the other ones, we're going to add 2 in pi to that. All right, so let's look at C. We have tangent squared of x minus 3. So let's get tangent of x alone. Right, now when we solve, just like regular equations, and when we solve these by taking the square root, we do have to do the positive and negative square root. Okay, so we have positive or negative. So this is going to be all 4 quadrants. So anytime you have plus or minus, it's going to be all 4 quadrants. Okay, and when you have all 4 quadrants, we can actually kind of shortcut it. So whatever angle, because we have plus or minus, whatever angle we get for quadrant 1, if we add in pi to it, it actually also gives you the angle for quadrant 3. And then same thing for quadrant 2. If we take an angle in quadrant 2, that's an answer to this, and we add in pi to it, it gives you your angle for quadrant 4. So that's a little bit of a shortcut, and we'll talk about that some more. All right, so we need to know what angle in quadrant 1 has a tangent of square root of 3 over 1. Now, if you guys remember, to find the tangent using the hand trick, it's the square root of the bottom over the square root of the top. So that means I want 3 bottom fingers, and even though we don't have it down there, I want 1 top. Okay. So we're looking at our hand. The angle that has 3 bottom fingers and 1 top finger is pi over 3. So there's the 3 bottom and the 1 top. So x is pi over 3. And then I'm going to add in pi to that. And it's also going to give me my angle in quadrant 3. All right. And then for pi over 2, for quadrant 2, we think about what pi over 3 is in quadrant 2 is going to be 2 pi over 3. And then plus n pi. All right, so that gives us all 4 quadrants. We'll do another one that's like that here. All right, so let's look at example B. I'm not going to fill in those blanks. I don't really think we need to. I think we're going to be fine. All right, so for D, let's go ahead and let's solve that for sine. There's going to be several steps. All right, so when we do this, we get plus or minus. That means all four quadrants. All right, and you guys try to get in the habit of when it's all four quadrants, it doesn't matter if it's sine, cosine, tangent, secant, cosecant, whatever. To do all four quadrants, you just have to add in pi. So you take quadrant 1, add in pi to it, it gives you quadrant 3. And then when you take quadrant 2, add in pi to it, it gives you quadrant 4. Okay, so if we're doing sine, we're doing the square root of the bottom over 2. So that means we want 3 bottom fingers. If we look at the hands, 3 bottom fingers is here, so that's pi over 3. So in quadrant 1, we have pi over 3. And then if we just add in pi to that, that also gives us our angle in quadrant 3. All right, and then the quadrant 2 angle for pi over 3 is 2 pi over 3. All right, and if we add in pi to that, it gives us our angle in quadrant 4. Okay, so all of these where you end up with a plus or minus, there's a little bit of a shortcut to give your answers. So try not to let that confuse you too much. It's okay. We'll talk more about it later too. All right, so for example 4, we're going to find all the solutions in the interval. So when you're given the interval, then you don't do plus 2n pi or plus n pi. You just give the angles. All right, so let's go ahead and solve this for sine of x. All right. So plus or minus means all four quadrants. All right, sine is the square root of the bottom over 2. So we want 2 bottom fingers. And we look at our hand trick. The finger that has 2 bottom fingers is pi over 4. So we want pi over 4 in all 4 quadrants. All right, so we're not doing plus n pi or plus 2n pi. So we just go ahead and list pi over 4 in all 4 quadrants. And there it is. Okay. So we have one more. So this one is it's in factored form, so we don't want to unfactor it. I know that like after what we've been doing lately, it feels like you need to, but if this is already in factored form and it's multiplication, that means that either sine of x is equal to 0 or sine of x plus 1 is equal to 0. All right, so we would solve this second one for sine of x by subtracting 1. Okay, so anytime you have the sine of x equals 0 or 1 or negative 1, or same with the cosine, we need to use that ordered pairs, the quadrant angles. All right, and when I say quadrant angles, this is what I mean. Okay, and so for sine on these quadrant angles, we use the y coordinate. So if I want the sine of the angle to be 0, I'm looking for an angle where the y coordinate is 0. Okay, and so that is going to be 0 and pi. But we're not quite finished because we have this one over here. And that one, we want the y coordinate to be -1. Right? And the angle whose y coordinate is -1 is 3 pi over 2. All right, so we have 3 answers to that one. All right. So I just want you guys to do that worksheet for your assignment, lesson 5, 3A worksheet.